Hi, I want to tell you about my talk about improving opinion mining using aspect-based sentiment analysis and Tensorflow. I'm Esther, and I'm an associate professor at Institute Sains dan Teknologi Terpadu Surabaya. I'm also the head of social network analysis and mobile computing lab, and the member of natural language processing lab. I also am a Google Developer Group Surabaya founder and organizer, and I went to Google I/O as seen in my profile picture, which is a very wonderful experience for me. Also, I have learned Android Cloud NLP on social media for 10 more years, and I have presented in more than 50 talks to communities about these technologies. I also have a hobby on playing piano and singing. That is my LinkedIn account and my GitHub link, which you can view more details about my presentation. My research experience is as a doctoral degree student at ITS Surabaya in 2020, where I completed with 4.0 GPA, and I have research collaboration with Tokyo University of Technology. This is two of my papers, which is multi-view sentiment analysis and social media emotion analysis based on BERT model. I want to ask you all a question. Have you ever wondered about what do users think about your product or service? And how can you monitor what they say and think in the social media, which is usually very truthful since it is what they think about. So when there's a product or service that they use, usually they just post it on social media when they think about it, right? Just at that moment. So because social media is very popular, sentiment analysis is also becoming very huge now because it can automatically check the data on social media and determine what users think. There are 4 types of sentiment analysis, which is sentiment detection, and this is a basic type, and then fine grain, which is more detailed about how much does a user like a product very much or just like it or doesn't like it or very hate it. So that is the fine grain sentiment analysis. And then there's emotion analysis, where we will determine what do we feel about the product. Are we happy or sad or angry, like that? So it's another field of research. And finally, what am I going to let you all know today is about aspect-based sentiment analysis, which has 3 main components, which is the entity, the aspect, and the sentiment. So more details about aspect-based sentiment analysis is it categorizes opinion by aspect and identifies sentiment related to each aspect. So what do we do with the result of sentiment analysis? We can monitor our brand on the social media. We can make decision about marketing strategies. We can check how user responds to our product, which is part of the public relation, and also we can do data or web or text mining. That is an example of a sentence in a social media post. The first sentence is: a doctor at hospital X was caring and helpful, but the whole hospital was so dirty. So here we have 2 parts of the sentence. One part shows positive polarity about the doctor, and the second part shows negative polarity about the cleanliness. So the basic sentiment analysis only detects one type of sentiment, but here it can be usually and easily misclassified. So with aspect-based sentiment analysis, we can determine each sentence and its parts accordingly. And why I use Tensorflow and why you should all use Tensorflow? It is the most popular deep learning library. We can work on deep learning and machine learning problems with it, and we can usually easily publish the models to the web, and also even mobile devices could also use TensorFlow Lite. My experiment and research is inspired from targeted aspect-based sentiment analysis via embedding common sense knowledge into an attentive LSTM by Yukunma. However, I added some modification and I added some parts to create a better performance. And this is my manuscript or paper that is now presented at INAS, International Journal of Intelligent Engineering and Systems, and I will let you know more details. And I hope you can also develop sentiment analysis models that can get details on each aspect. So before moving on, I will explain about the data set. So I built the dataset together with my team at the Social Network Analysis Lab at our campus, and the model was built and labeled from 9,859 5 major US hospital reviews. And there are several aspects as displayed. This is the example of the data, and this is the data scraping. So I obtained the reviews from Google Map reviews, and I save it in my data set. So from hospital care reviews, I collect the data and pre-process it and got the features, which is aspect, characters, word token, and position. And then each of these data was input into the aspect embedding, character embedding, and word embedding. Then I use bidirectional LSTM, character instance token embedding, finally the dropout layer, and bidirectional GRU. And the last step is multi-level attention, which is also the model that I want to show you that is very effective in sentiment analysis. The preprocessing contains tokenization indexing, and then I also use gated recurrent unit because it is more better than LSTM, which is very popular for text classification. This is the example for the code for aspect embedding, which I embedded the aspects into the model, and then for character enhanced token embedding, I represent a character in the form of vector. Character enhanced token embedding helps us to handle out of vocabulary words. And then I combine it with BiLSTM. And also the special part about my proposed model is multi-level attention. In a sentence, there are several words, and we can make sure that the important words are highlighted. So here, the green color shows that it is important words, and the red is not important words. For example, like kind and is not too important. But nurse and receptionist must take our attention. So attention makes us take more knowledge and information on important parts of the sentence. This is the example of the initialization of the sentence level attention. This is the flow of my code. So I started a TensorFlow session, initialize neural network, and train the model, and save the model to get the prediction. I also handle the dataset, which is in the XML format, and I obtain the concept, I tokenize it, and obtain opinions. I also listed the characters in a token, and then I conducted indexing before saving it into the dataset. Also, there's affective space, which is inspired by the previous paper from Yukunma, which is also used in my model. This is the predict code where I finally combined the attention and then conducted prediction to make the final model. The result is very promising, which our model obtained the highest score compared to the previous model that is inspired for our research. And then I also conducted experiments on several datasets to make sure that my model also works well in various datasets. For better information, I also had experiments on Singapore hospitals. I saved the reviews before and during COVID pandemic to know which part or which aspect has a change. So in this diagram, before COVID-19, most of the reviews discusses the doctor. However, here we can see that after we can see that there are more discussion about how about the waiting time and the receptionist like that. So you can see the differences. And this is the word diagram about what are the topics before the pandemic situation and then after the pandemic situation. As we can see, the problem is waiting, because maybe when we go to hospital after the pandemic, we have to have several checkups before being able to be served by the doctors or nurses. So I could share you more information from my various experiments that bidirectional crew is quite good to perform for classifying sentiment. And also character enhanced token embedding helps to resolve spelling errors that is usually shown in social media. Thank you for your attention.